is ellipses. So what we're going to look at today is ellipses, writing the portion and whatnot. Now, the second type of conic section is called an ellipses. It is defined as follows. An ellipses is a set of all points x, y in a plane, the sum of whose distances from two fixed points, called the foci, is constant. So pretty much if we connected a rope to these two foci and drew it around in a circle, all those points on the ellipses would be the same. So the distance from here to here and here to here, the overall distance added, these two added together, will be the same at any point on the ellipses. So as it moves from any point around here, well, at this point over here, distance 1 would be smaller than this distance 1. But the distance 2, d2, would be bigger, and that change offsets each other. So no matter where we're at on the circle, we would get the same length. Questions on this here? Now, let's see if I can find the mouse. There we go. Okay. Now, the lines through the foci intersect the ellipses at 2 points called vertices. So it intersects the 2 points. The chords joining the vertices is the major axis, and its center is the midpoint. So along the major axis, its center is the midpoint of that. The chord perpendicular to the major axis is called the minor axis. So the major axis is always going to be longer than the minor axis, and we're going to denote major with A, minor with B. And the major axis itself is actually 2A, because A values just from the center to the vertex, to the ellipses itself, and the minor is from the center to a point on the ellipses in that line. You can visualize the demonstration by imagining 2 thumb picks placed at the focus as shown below. In the end of the fixed length, string are fastened to the thumbtack, and the string is drawn taut with a pencil, then the path traced by the pencil will be an ellipses. Questions on this here, or kind of how this works? Okay. Well, now the ellipses is going to have a center h comma k. It's going to have the vertices of h plus or minus a comma k, and as we said, a is the major axis, and the focus and the c value is really generated from kind of a and b, because b squared plus c squared is going to give us kind of the hypotenuse from the vertice to the minor axis or major axis, depending on which direction. Well, it's going to be always minor. And a is the overall length here. So b squared plus c squared is equal to a squared. So we have this here. Using the vertex points, this constant sum is a plus c plus a minus c is equal to 2a, the overall length. That is, we get this equation here, we can work through. But really, our overall formula is what's important for this here, that x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now this is if the major axis is along the horizontal, if it's horizontally. or parallel to the horizontal. Because you would attain a similar equation in the derivation, I can't even read, by starting with the vertical major axis. So if it was, the major axis was vertically, not horizontally, going straight up and down, A and B would be switched. So this here, so we're looking at one like that. Now, if we had it switched, x minus h squared over b squared plus y minus k squared over a squared equals 1. It would be elongated vertically. Now, the main difference that we can deviate between A and B is A is always going to be greater than B. So these are our two equations as we saw. Major axis is horizontal, major axis is vertical, where 0 is less than A is less than, 0 is less than B is less than A. A is always going to be the bigger of the two axes. The focus lies on the major axis, C units from the center, with C squared is equal to A squared minus B squared. If we have the two major axes, we can find those there. Now, if we have the major axis in C, the focus, we can find the value of B, and vice versa. Because if I have what the focus is, the C value, the distance from it, then we can find A and B accordingly. Now, it does work out if the center is on the origin 0, 0. We have these here. Essentially, we're plugging in 0 for H and K. So the major axis is horizontal. We get this here. A is connected with X. When it's vertical, A is connected with Y. From the standard equation of the ellipses having a focus of 0, 1, and 4, 1, and a major axis of a length of 6, as shown in the figure. Well, we know the center is at 2, 1, so the value of C is 2, and the value of A is 3. Because we can look at the points and see, okay, we have a distance of 2 from the center. Well, also the center is exactly in the middle of 0, 1, and 4, 1. So 0 plus 4 is 4 divided by 2 is 2. So it gives us the overall center. And we can use this to go on and figure out the rest of it from here. Now, because of this here, we know that the focus is C. So 2A is equal to C, so we know A is 3. So this, again, this is using a lot of just the basic equations to find it. Now, any questions on this so far? So this main part here is the fact that 2A is equal to because 2A equals 6. 2A, oh yeah. Okay. They gave us the length of the major axis. Major axis is 6, so we divide it by 2 to get 3. That's how we get the value of A. So that's how we got A is equal to 3. So now we can plug in this equation, the fact that A is 3 and C is 2. 3 squared minus 2 squared is going to be 5. 9 minus 4 is 5. So the value B is 5. Our minor axis is 5. Now we know the center is at 2, 1. 2, 1. As we know, the major axis is horizontal. The bigger value would be with X, smaller value with Y. And we would square it to get this here, because 3 squared would be 9, the square root of 5 squared is 5, and this would be our overall equation. Questions on this here? Okay, because then we can use application and do this with planets and get the same type thing. Now, okay. Okay. Let's go on and look at more examples, because that's about it for that there. Switch. Okay. Now what we want to do for this here is we want to find the equation of the ellipses given these characteristics, and the center is at the origin. So since the center is at the origin, 0, 0, our h and k values are both 0. So we'd have x minus 0 squared, and y minus 0 squared is equal to 1. Now looking at this here, we need to find our major and minor axes, or the lengths of them, the lengths of A and B. Well, looking at this here, because this here would be a distance of 4, and this here would be a distance of, because 3.5 plus 3.5 would be 6.5, which would be 3/2 plus 3/2. Because the overall distance is what we're looking at. So we'd add the two together and take the absolute value of it. Because the distance from 0 to 3/2 is 3/2 or 1.5. Going straight down would be 1.5. 1.5 and 1.5 would give us 3. Now, A and B, well, 4 is definitely bigger than 3, so the value of A is actually, and B is 3/2. So, since this is horizontal, our bigger value would go with x. So we'd have it squared, and then our 3/2 squared would go with y. And now we just need to simplify this here. Now luckily for us, well, x minus 0 is just going to be x squared over 4 plus squared over 9/4. Even more, dang it. I'll get it later. Now, the 9/4 luckily will flip and multiply. So we get x squared over 4 plus 4y squared over 9. Because when we divide, we have to change it from division to multiplication. So the 4 would go on top and multiply with our y. Does that make sense? Or do y'all need to see that written out? You're good? But this here would be the equation for this here, for this ellipses. Does this make sense of how we got to this here? Okay. Because we're going to do some more. Now we're given the vertices of plus or minus 7, 0, and a foci of plus or minus 2, 0. So we have this here. Now we can look straight at the formulas to get at what the answer, or kind of get towards our result, but it's sometimes nice to look at a graph. Now one of the best graphing calculators that we have with online is going to be Desmos. So you can Google Desmos graphing calculator. It does very well at graphing most of these here, so we can use it to graph points as well as actual equations. So if we were to graph these points, we would get this here. had plus or minus 7. So these are our vertices. And these are our foci. So, and we know that this here is still focused at the center, so H and K are still 0. Which got a nice, which means C is 2, and A is 7. So here, C is 2, A is 7. And as we see here, it's still bigger on the X. Now to find B, well, B is equal to the square root of A squared minus C squared. So that'd be the square root of 7 squared minus. Yes. Now we can leave it here, because again, what we're wanting to find is the overall equation. So for us, it'd be x minus 0 squared plus y minus 0 squared equals 1. Now again, we're longer on the major axis along the x, so it would go with the x. So our a value is 7. B value is the square root of 45 squared. So the reason we don't have to worry about it too much is, well, we'd have x squared plus y squared. That would be because we could have gone through and said that the square root of 45 is the same as 3 square root of 5, because 9 times 5 is 45, square root of 9 is 3. But when we square it back, it turns us right back into 45. So it really doesn't make a big difference if we had it simplified or not. Questions on this here? So we good with this here? Well, let's go on and pull Desmos back up. There's a nice thing about Desmos, and unlike your graphing calculators, Desmos does not have to have it in y equals form. And if we look at this here, the two vertices that we listed from the beginning are actually intersected with our equation. It goes through both of these points. And if we went through and figured out in a graphing calculator 3 squared of 5, it should give us 6.708. Because the square root of 5 is a irrational number, non-terminating, non-repeating decimal. Questions on this here? All right. We've got the foci, 0 plus or minus 3. And the major axis length is 8. So our a value is because the major axis length is not just a, but it's 2a. It's going all the way across. A is just from the center of the circle to the point. It's half of the overall major length. Now C, in our case, would be 3, because C is going to be from the center to the foci. So really, at this point, all we need is the value B, which would be the square root of a squared minus is 7. Now, this here, again, the center is still at 0, 0. It's still at the origin. For all these ones that we're doing, the center is at the origin. So we really just have x squared and y squared, because it'd be x minus 0 squared and y minus 0 squared, which is just going to be x and y. Now, a is going to go where? Because now our focus is straight up and down, because the focus is always going to go in line with the major axis. Because on the last one where we saw the two focus point and the major axis were all in line, here it's going up and down. So that means our square root of 7 squared will be with x. So if we simplify this here, we'd have x squared over 7 plus y squared over is equal to 1. Yeah, that's actually what's, we'll do that here in a second. I want to do one more on the origin, and then we'll move to not on the origin. So the last one we're going to look at the origin is the horizontal is our major axis. So our major axis is parallel to the horizontal. So that means we're talking about x. Now, it passes through the point 5, 0 and 0, 2. So those are 2 points on the ellipses. So a major axis is along the horizontal. So our center is at 0, 0. 5, 0, 0, 2. Well, here A would be what? We have this length of 2 and this length of, so A would be, B would be. Since we still know it's on the origin, x squared and y squared, below x we would have 5 squared, which is nope, because it wasn't talking about the focus. All right. Off the try to draw this here. It looks like a balloon. 2, 0. 2, 6. 3, 3. And this is 1, 3. And we want to find the standard equation for this here. Now we know the center, if we drew straight lines from here to here and here to here, if everything worked out accordingly, where these two intersect would be the center. Now it's interesting for this here, well, if we notice the x values for the, what looks like to be major axis is both 2, yes? So the center's x would be 2, 3. Because these are all 3 y values, these are all x of 2, so the center has to be at the point 2, 3. Does that make sense? Now, when we look at the overall distance, well, the distance from 0 to 6 on the y, well, this gives me a total distance of, and here to here is a total distance of 2. So, A in this case and B in this case, since the bigger number is 6, A would be y, and it would be 3, because 6 divided by 2 would be 3. The smaller overall length would be 2, so B is 1. Now this time we will have x minus, y minus, well here x minus 2 and y minus 3, because h and k in the equation is the center. Now, since it's longer along the y, our value of a would go with the y, and 3 squared would be, and 1 squared would be 1. Or if we really wanted to, we could just write it as 2 squared plus y minus 3 squared over 9 equals 1. And that's all we'd have to do for this here. Questions on these here? All right, so we'll stop here for today.